Welcome to this explainer. Okay, let's dive right into this because today we're taking a mind-bending journey. We're going from our tiny little planetary neighborhood all the way to the absolute edges of the observable cosmos. We're going to zoom out, layer by layer, just to try and grasp the staggering scale of the reality we actually live in.
But, to really understand the massive spatial scaling we're about to experience, we've got to start right here at home. Carl Sagan put it perfectly. He called Earth a tiny blue dot floating in the immense cosmic ocean. I mean, think about it. Right here resides everyone you've ever known, every single story ever told. It's just a small speck in this immense universe. And to see what's truly out there, well, we have to leave Earth's embrace.
So, our first outward step brings us to the moon. It's our closest celestial companion, right? Yet it still sits roughly 384,000 kilometers away. Even from this first, relatively small leap, if you look back, Earth just appears as this fragile little sphere of blues and greens cradled in the absolute black void of space. It honestly instantly puts our whole existence into a pretty humbling perspective.
Now, to ground that immense distance into something we can actually wrap our heads around, 384,000 kilometers is a massive number. But consider this. If you were to hop into your car right now, point it straight up into space, and drive at a constant highway speed of 100 kilometers per hour, it would take you over 160 days, over 5 months of non-stop driving, 0 bathroom breaks, just to reach the moon. Okay, so as we shift our focus to the sun, which is about 150 million kilometers away, using kilometers starts to become, well, completely impractical. So astronomers shift the cosmic ruler to something called the astronomical unit, or AU. 1 AU is exactly that distance from Earth to the sun, and this becomes our brand new standard measuring stick for the solar neighborhood. And this speed comparison here perfectly captures the vastness of just our inner solar system. Let's compare the ultimate speed limit of the universe to human aviation. Light, which travels at an absolutely astonishing 300,000 kilometers per second, takes about 8 minutes and 20 seconds to reach us from the sun. But if you boarded a commercial jet flying at 900 kilometers per hour, that exact same journey would take you 19 years.
Venturing beyond our home planet and the sun, we set our sights on our enigmatic red neighbor, Mars. Now, while it can be 54.6 million kilometers away at its absolute closest approach, the complex orbital dynamics out there stretch that distance up to a staggering 401 million kilometers when our planets are on opposite sides of the sun. Taking that same commercial jet across this constantly changing expanse, that would take upwards of 50 years.
So as we keep zooming out to the outermost reaches of our planetary system, we hit Neptune. This distant ice giant marks the edge of our solar neighborhood, lying roughly 4.5 billion kilometers from Earth. To put the sheer enormity of that gap into perspective, the light from our sun actually has to race across the vacuum of space for 4 hours and 15 minutes just to reach Neptune's icy clouds.
The crucial takeaway here is understanding just how tiny humanity's physical reach actually is in all this vastness. Just look at Voyager 1's timeline. Launched way back in 1977, it's basically humanity's ultimate scout. In 1990, it captured that iconic pale blue dot photograph looking back at Earth from 6 billion kilometers away. And today, over 4 decades later, it's 22 billion kilometers away. Our farthest human-made object is really just a silent wanderer out there in the cosmic sea.
Looking far past Voyager, we encounter the Oort cloud, which is this vast sphere of icy objects extending up to 100,000 astronomical units. And right at the edge of this domain is the heliopause. This is the ultimate boundary line. It's the exact zone where our sun's solar wind is finally stopped by the interstellar medium. Literally the place where the influence of our home star fades away and the true, dark expanse of interstellar space actually begins.
And out here in interstellar space, the astronomical unit, it completely loses its utility. The gaps are just way too massive. So once again, our measuring stick has to evolve, and this time we shift to the light year. This is the distance light travels in a single Earth year. And honestly, it is the only practical way for astronomers to measure the terrifyingly large voids between neighboring stars.
To show you exactly why we need this massive new ruler, let's look at Alpha Centauri. This is our closest neighboring star system, and it sits 4.4 light-years away. That translates to over 41.3 trillion kilometers.
I mean, the enormous distances we just spent all this time covering to get to the edge of our solar system, they are absolutely nothing compared to the empty void between our sun and its closest neighbor.
Just let this next number sink in for a second. 70,000 years. If Voyager 1, which, remember, is traveling at a blistering speed of 17 kilometers per second, were aimed directly at Alpha Centauri, it would require this immense amount of time just to reach our closest stellar neighbor. It makes our current concepts of interstellar travel seem almost completely unfathomable, right?
Now let's put our tiny galactic footprint into perspective against the sheer grandeur of our home galaxy. The Milky Way is a vast spiral spinning out there, spanning 100,000 light-years in diameter, and it contains hundreds of billions of stars. Yet the absolute farthest extent of human influence, basically our radio and television broadcasts, creates a human radio bubble that is only 100 light-years wide. Beyond this microscopic little bubble, our entire recorded history is completely undetectable in the cosmic wind. No one would even know we're here.
Okay, so it's time to take an even more massive step back. We're going to walk through our nested cosmic address now. Step 1, the Milky Way. Step 2, the local group. Step 3, the Virgo Supercluster. And Step 4, the Laniakea Supercluster. We're zooming out further and further until the entire Milky Way, along with its hundreds of billions of stars, is reduced to a literal microscopic speck in a much, much larger intergalactic ocean.
Leaving the Milky Way behind, we enter the local group. This is a cluster of more than 50 galaxies, including ours and Andromeda, spread across 10 million light-years. The intergalactic space here is just a silent expanse. It's a vast, empty wilderness between these islands of galactic light, where light itself would take 10 million years just to travel from one end to the other.
And the scale just keeps expanding. Extending our gaze beyond the local group, we hit the Virgo Supercluster. It is 110 million light-years across, which forces us to introduce yet another metric, the megaparsec. At 33 megaparsecs wide, this titanic structure contains thousands of galaxies and encompasses at least 100 entire galaxy groups and clusters. It's just mind-boggling. But as incredible as it is, the entire Virgo supercluster is actually just a tiny component caught in a much, much larger cosmic web. Zooming out again, we arrive at the Laniakea Supercluster, meaning immense heaven in Hawaiian. Laniakea stretches across 500 million light-years and contains the mass of 100 million billion suns. It is a gravitational masterpiece on a scale that honestly just defies standard human comprehension.
So what orchestrates this immense heaven? Well, at the very heart of Laniakea lies the Great Attractor. This is a highly mysterious region of space that exerts a massive, almost incomprehensible gravitational pull. It literally dictates the motion of countless galaxies, including our very own Milky Way. It's a hugely humbling reminder that we are just tiny little participants getting swept up in this majestic cosmic dance. Finally, as we reach the utmost boundaries of our cosmic exploration, we encounter the limits of the observable universe, 93 billion light-years in diameter. Just let the sheer, incomprehensible scale of this final astronomical marvel sink in for a second. Every galaxy, every supercluster, every single celestial wonder we have discussed so far today, it all sits inside this staggering expanse.
Now, comparing these massive scales, you might actually spot an apparent paradox here. If the universe is only 13.8 billion years old, how on earth can the observable universe be 93 billion light-years across? Well, the answer lies in the very nature of cosmic expansion. Ever since the Big Bang, the universe has been literally stretching space itself, actively increasing the physical distances between all celestial bodies. It's not just things moving through space, it's space itself expanding.
Which leaves us with this final, incredibly provocative thought. What actually lies beyond the observable universe? Because space itself is expanding faster than the speed of light in some regions, there are endlessly retreating galaxies and cosmic wonders that we will simply never, ever witness. They're forever out of our view. The true size of the entire universe is completely unknown, and it's potentially infinite. We really are just a fleeting spark on a pale blue dot looking out into an ever-expanding mystery.